So again, when we're proving something, we can use anything other than that thing. If you were in a true proof class, you would build everything up to the point that you were proving the thing that you were trying to prove. So here we're going to prove alternate exterior angles theorem. So we're going to prove that angle 2 is congruent to angle 7, and we're given that L and M are parallel. So we know that L is parallel to M. That's just given to us. And then we're trying to prove that angle 2 is congruent to angle 7. So I'm going to use angle 3 as my intermediary. So I can say that angle 2 is congruent to angle 3 because these are vertical angles. So this is by the vertical angle theorems, which says that vertical angles are congruent. We proved that earlier. And then we're going to say that angle 3 is congruent to angle 7 by the corresponding angles theorem. Remember, this is theorem, not converse, because we're not proving parallel lines. We're just proving angles are congruent here. So from that, I now have this middleman that I can cut out. I can say that angle 2 is congruent to angle 7 because of the transitive, because I'm cutting out a middleman, property of congruence, because we're talking about congruence, not equality. All right, let's take a look at this proof of same side interior angles. So we're going to be proving that the measure of angle 3 plus the measure of angle 5 equals 180 degrees. And I'm going to go through let's go through angle 7. So we're going to be using angle 7 as our intermediate. So I know that L is parallel to M. That's given to me. So I know that angle 3 is congruent to angle 7 because these are corresponding angles. So we're doing the corresponding angle theorem. Okay, and so from there, I know that the measure of angle 5 plus the measure of angle 7 equals 180 degrees because they make a linear pair. So linear pairs are supplementary. Okay. So now we can replace angle 7 with angle 3 because they are congruent. So I can now say the measure of angle 5 plus the measure of angle 3 equals 180 degrees. And this is by substitution. Notice that I said substitution this time. T-U-T-I-O-N. I can get there eventually. This time it's substitution, not transitive property, specifically because we're not cutting out a middleman. We are going straight from angle 7 to angle 3. There's no middleman that's making it equal to something else in between. All right, and we have one more proof to do. This is going to be same side interior angles converse. So this time our goal is to end with they are parallel. So we're given that angle 3 and angle 5 add to 180 degrees. So I know that the measure of angle 3 plus the measure of angle 5 equal 180 degrees. And I'm going to try and go through corresponding angles because why not? So I'm going to go from angle 3 to angle 1. So I know that the measure, oh, and that was given. We should write given. Let's not forget our reasons. Given. Fantastic. Okay, so then we've got the measure of angle 3 plus the measure of angle 1 equals 180 degrees. And this is because linear pairs are supplementary, right? So now we've got two angles that are supplementary. So let's go ahead and use the transitive property to set them equal to each other. So we can say that the measure of angle 3 plus the measure of angle 5 equals the measure of angle 3 plus the measure of angle 1. So that is just through either you can write the transitive property of equality, or you can say that it is the substitution property. I don't really care which. See, I can get there eventually. I just have to sound it out. Transitive property of equality. Fantastic. All right, so from here, I notice that I have two angle 3's on both sides. So if I subtract the measure of angle 3 from both sides, I end up with the measure of angle 5 is congruent to, or is equal to, oop, my bad, I added a squiggle too early, the measure of angle 1 by the subtraction property of equality. Okay, so from here, because they're equal, we can use that definition of congruence to say that angle 5 is congruent to angle 1, and this is just the definition of congruence. And then our last step is to say that L is parallel to M by the corresponding angles. Instead of theorem, this time we're going to say converse, because we are proving that those lines are parallel, knowing that the corresponding angles are congruent. All right, with that, that is all I've got for you today, and we will meet back in 6.3.